Once again, good day grade 9 students. This is the video of our second lesson for this week, which is the sum and product of the roots of quadratic equations. Our objective is to describe the relationship between the coefficients and the roots of a quadratic equation. Alright, let us begin with a review of writing the quadratic equations into standard form. Ax squared plus bx plus c is equal to 0. And then let us identify the values of a, b, and c. Let us have number 1. X squared is equal to 2x plus 3. What do you think in standard form? Right, that is x squared minus 2x minus 3 is equal to 0. Where a is equal to 1, b is equal to negative 2, and c is equal to negative 3. Next, number 2. 9y times the quantity y minus 3 is equal to 0. Here we need to multiply first the left side of our equation, and it will give us 9y squared minus 27y is equal to 0, where a is equal to 9, b is equal to negative 27, and c is equal to 0. Next, number 3, we have 15x squared is equal to 0. In this equation, it is already written in the standard form, so therefore let us write it in the second column. That is 15x squared is equal to 0. So our a is equal to 15, b is equal to 0, and c is equal to 0. Next, number 4, we have 19m squared is equal to 7. By addition property of equality, it is written in standard form as 19m squared minus 7 is equal to 0. Where a is equal to 19, b is equal to 0, and c is equal to negative 7. Lastly, we have the product of the binomials x plus 6 and quantity x plus 5 is equal to 0. Getting the product of the binomials on the left side, it will give us x squared plus 11x plus 30 is equal to 0, where a is equal to 1, b is equal to 11, and c is equal to 30. To start our discussions, in the quadratic formula, x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a, let us derive the sum of the roots. Let us denote the sum of the roots as r sub 1 plus r sub 2. From the quadratic formula, let us separate the roots as negative b plus the square root of b squared minus 4ac all over 2a, and then the other one is negative b minus the square root of b squared minus 4ac all over 2a. As you notice, the roots now of the quadratic equation is presented as fractions having the same denominator of 2a. Let us proceed now. The sum of the roots r sub 1 plus r sub 2 is equal to negative b plus negative b is equal to negative 2b. Square root of b squared minus 4ac plus negative square root of b squared minus 4ac is already 0. Now let us copy the denominator, which is 2a. Let us simplify. R sub 1 plus R sub 2 is equal to negative 2b divided by 2a is equal to negative b over a. What do you think is the significance of this formula? Let us illustrate. Suppose we have a quadratic equation, x squared minus 4x plus 3 is equal to 0, and we need to find the sum of the roots, but we do not know the formula. Our next move is to solve for the roots. By factoring, x squared minus 4x plus 3 is equal to 0 will be written as the quantity x minus 3 times the quantity x minus 1 is equal to 0. Setting each factor equal to 0, x minus 3 is equal to 0, and solving for the equation, it will give us one of the root as 3. And then the other one, x minus 1 is equal to 0. Solving it, we have the second root as 1. Solving for the roots of this equation, we have r sub 1 plus r sub 2 is equal to 3 plus 1. So the sum is equal to 4. In this process, we first solve the roots in order to find the sum. So it is more tasky compared to using the formula r sub 1 plus r sub 2 is equal to negative b over a. We will just use the coefficients of b and a. So from our equation, our b is negative 4 and our a is 1. So we have r sub 1 plus r sub 2 is equal to negative of negative 4 over 1. Negative of negative 4 over 1, so we have now the sum as 4. As you notice, we have the same answer but of different methods. Therefore, the sum is 4. Doing the same process, let us use the quadratic formula x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a in discovering the product of the roots. Let us denote the product of the roots as r sub 1 times r sub 2. Then, let us separate the roots of the quadratic equation as negative b plus the square root of b squared minus 4ac all over 2a. And then the other one is negative b minus the square root of b squared minus 4ac all over 2a. Notice that we have now the product of the sum and difference of two binomials since we have the same first terms, and that is negative b over 2a. And then we have also the same second terms. We have the square root of b squared minus 4ac all over 2a, and they only differ in the operation. We have the sum and then the difference. To get the product of this, just get the product of the first term followed by the product of the second terms. So we have r sub 1 times r sub 2 is equal to negative b times negative b is equal to b squared. Square root of b squared minus 4ac times negative of square root of b squared minus 4ac is negative of the quantity b squared minus 4ac. And then 2a times 2a is 4a squared. Let us simplify the numerator. So we have r sub 1 times r sub 2 is equal to b squared minus b squared plus 4ac. It is already positive 4ac because negative times negative 4ac is already 4ac. And then copy the denominator, which is 4a squared. Simplifying again, b squared minus b squared is already 0. Then we have r sub 1 times r sub 2 is equal to 4ac all over 4a squared. 4ac over 4a squared is equal to c over a. So this is our formula for the product of the roots. To illustrate its importance, let us use again the quadratic equation x squared minus 4x plus 3 is equal to 0. Again, by factoring, we have quantity x minus 3 times the quantity x minus 1 is equal to 0. From here, our first root is equal to 3, and then the other one is equal to 1. Getting its product, we have r sub 1 times r sub 2 is equal to 3 times 1, and that is 3. But by using the formula, we have r sub 1 times r sub 2 is equal to c over a. From our quadratic equation, our c is equal to 3 and our a is equal to 1. So we have r sub 1 times r sub 2 is equal to 3 over 1, and that is also equal to 3. Notice that we have the same value of the product of the roots, and that is 3, but using different method. But the answer are just the same, and then the product of the roots is equal to 3. Now let us have an illustrative examples. Let us find the sum and product of the roots of each quadratic equations. Let us have now the given standard form, the value of a, b, and c. Then we have the sum of the roots and then the product of the roots. Let us have number 1. X squared minus 12x is equal to negative 36. In standard form, it is x squared minus 12x plus 36 is equal to 0, where a is equal to 1, b is equal to negative 12, and c is equal to 36. The sum of the roots, that is negative b over a, since our b is negative 12, so that is negative of negative 12, which is positive 12 over 1, so our sum of the roots is 12. The product of the roots is c over a, so that is 36 over 1, so that is 36. Next, number 2. 4x plus 3 is equal to negative 5x squared. In standard form, it is written as 5x squared plus 4x plus 3 is equal to 0, where a is equal to 5, b is equal to 4, and c is equal to 3. The sum of the roots is negative b over a, so that is negative 4 over 5. And then the product of the roots, that is c over a, so that is 3 over 5. Lastly, we have 6x squared is equal to 5. In standard form, it is 6x squared minus 5 is equal to 0. Our a is equal to 6, our b is equal to 0, and our c is equal to negative 5. The sum of the roots, which is negative b over a, that is 0 over 6 or 0. And then the product of the roots, which is c over a, that is negative 5 over 6.